Welcome to UVU CS3060 Lecture 4.1, where we discuss various threading models that exist within user and kernel threads. There are three threading models that we're going to talk about today. We're going to talk about the many-to-one model, the one-to-one, and many-to-many model. Now, this first part usually refers to the user kernels or user threads, and this refers to the kernel threads. So if you see something such as many-to-one indicates that there are many user threads to one kernel thread. Now let's go ahead and see what this means. So in a many-to-one situation, you usually have many user-level threads, and all those user-level threads are mapped to one kernel thread. Now, the problem with this particular model, this model is available to any system. We can do this under Linux, we can do this under Windows, we can do this in MS-DOS if we so choose. A many-to-one works on almost every system, but nowadays, few systems actually use this. It's very rare to see a many-to-one situation. The big problem is if we have many threads here and we have a user library that is switching back and forth between these threads, if that user library is running a particular thread code and the kernel blocks, perhaps this particular thread performs some form of I/O, that I/O operation has to complete before any of the other threads can be switched to, because when this thread blocks, this blocks as well. The controller or the thread scheduler will block if any of the threads block. And this is usually a problem when it comes to actually running multiple threads on a multi-core system. They won't be, they cannot run in parallel, simply because parallelism is going to be controlled by the operating system kernel. And to the operating system kernel, all these threads are just one process, one task. You can see these particular many-to-one models in Solaris Green threads, as well as GNU portable threads. The one-to-one model, on the other hand, is actually fairly common nowadays. For each user-level thread, there will be a kernel thread. And so generally what happens is whenever a user-level thread is created, a new kernel thread is also created. So whenever we call fork, then we get a new kernel thread. Then when that particular process calls pthread create, on any one of these, it's going to create a new kernel thread. Now this kernel thread can be a full process, or it can be the efficient, smaller kernel, the process control blocks for a thread. Now, one major problem with, and because you have these threads running on their individual kernel threads, these user threads can run parallel to each other, can run on multiple cores at the same time. You can also have a scheduler. The kernel scheduler can schedule these particular threads in a concurrent manner on a single process. Now, we also have an issue where we need to consider the number of threads. Okay, the number of threads that are created can potentially overwhelm a system. Now, if we think of the many-to-one, if we create a 10,000 threads, it really only creates one kernel thread. 10,000 threads is just a very large process that has lots of switching going on between. But in a one-to-one situation, if we have 10,000 threads, we're going to have 10,000 kernel threads as well. 10,000 user threads can overwhelm a system, and so there needs to be controls such as limitations on the number of kernel threads or number of threads that a process can generate. We see the one-to-one model in Windows, we see the one-to-one model in Linux and Solaris 9. It is, as I said, the most common threading model now. There is another model called the many-to-many model. Now, in the many-to-many model, what happens is the operating system creates a certain number of kernel threads. So we have here 3. That's how many is created to start out with. Now, in a many-to-many model, this is the limit to the number of kernel threads that are created. Now, if we have 4 threads that are created within a particular process, then those 4 threads are assigned to one of these kernel threads with, so let's say this one is assigned to 1, this one is assigned to 2, and this one is assigned to 3. This one will wait its turn until maybe one of these particular threads blocks. If a thread blocks, then the kernel can switch to another user thread. Say this thread 2 decides it's going to do some I/O, in which case it's waiting now, and this goes on kernel thread 2. So we have a many-to-many model here controlling the number of kernel threads. If we have 10,000 user threads up here, but only 3 kernel threads, there will be a lot of swapping, but it will still be a system that's in control. Now, sometimes we have a 2-level model where we can have a system where we have many-to-many threads, but then we can choose to have one user-level thread associated to one kernel thread. So in this particular model, you have the option of running having the safety of a many-to-many model, but then being able to transition a user thread over to one kernel thread and allow that to function without this switching. Thus, if this thread blocks, this kernel thread will block as well. And that brings us to the end of lecture 4.1, where we talk about threading models.